This presentation will focus on omega-6 and omega-3 polyunsaturated fatty acids in inflammation, a precursor of cardiovascular disease. Linoleic acid is the primary member of the omega-6 family, which also includes arachidonic acid and gamma-linolenic acid. The primary member of the omega-3 family is alpha-linolenic acid, and it's a precursor of eicosapentaenoic acid, also known as EPA. Another prominent member of the omega-3 family is docosahexaenoic acid, also known as DHA. Docosapentaenoic acid and stearidonic acid round out the group. The only lipids for which dietary reference intakes have been established are omega-6 linoleic acid and alpha-linolenic acid, shown on the next slide. The grams per day represent daily goal amounts, also called adequate intakes, formulated for the physiological requirements of healthy people. There is no cardio-specific requirement for this nutrient. These are the AIs, or daily goal amounts, for alpha-linolenic acid. Alpha-linolenic acid is one of several anti-inflammatory omega-3 fatty acids, others being DHA and EPA, for which no AIs have been established. Again, there is no cardio-specific requirement for this nutrient, but failure to meet the AI represented here would mean its shortage in the body, which has potential implications for cardiovascular disease. Omega-6 and omega-3 are precursors for the synthesis of eicosanoids, locally acting signaling molecules that have wide-ranging functions in the body's cardiovascular, pulmonary, immune, and endocrine systems. Human inflammatory cells contain high amounts of omega-6, in particular arachidonic acid, a precursor for the synthesis of a number of pro-inflammatory eicosanoids, whereas eicosapentaenoic acid, or EPA, is a key anti-inflammatory omega-3 fatty acid. Eicosanoid products synthesized from omega-6 fatty acids, in particular arachidonic acid, include specific prostaglandins, thromboxanes, and leukotrienes that are more potent mediators of thrombosis and inflammation than similar products derived from omega-3 polyunsaturated fatty acids. The eicosanoid metabolic products from arachidonic acid are biologically active in very small amounts and contribute to the formation of thrombus, atheromas, and inflammatory disorders, particularly in susceptible people. Those susceptible may be persons with genetic variants, for example, of 5-lipoxygenase, in whom arachidonic acid and linoleic acid increase the risk of cardiovascular disease, whereas dietary intake of EPA and DHA decrease their risk. Omega-3 exert anti-inflammatory effects, for example, by suppressing pro-inflammatory interleukin-1b, tumor necrosis factor alpha, and interleukin-6. The typical U.S. eating style is excessive in omega-6 and deficient in omega-3. Therefore, the ratio of omega-6 to omega-3 is high, which is pro-inflammatory and promotes the pathogenesis of cardiovascular disease. Unlike the Mediterranean diet, the American diet ratio of omega-6 to omega-3 is 15 omega-6 to 1 omega-3 due to overconsumption of omega-6 vegetable oil and intake of animal foods that are high in omega-6s relative to omega-3s. As the percent of energy intake from linoleic acid increased, so did LDL oxidation in a human trial. Diets enriched with linoleic acid increase the linoleic acid content of LDLs and their susceptibility to oxidation. A diet rich in omega-6 shifts the physiological state to one that increases the atherogenicity of LDL. Higher intakes of omega-6 fatty acids do not reduce the risk of cardiovascular disease. Increased intake of linoleic acid, besides leading to oxidation of LDL and platelet aggregation, interfere with the incorporation of omega-3 fatty acid into the phospholipid membrane of the cell, where ordinarily it could displace omega-6 and exert anti-inflammatory effects that spread throughout the cell. Epidemiological studies and clinical trials did not find that selectively increasing omega-6 and reducing omega-3 reduced cardiovascular disease risk. However, the optimal omega-6 to omega-3 ratio would vary by disease according to genetic variations. But some research has found that the DHA to EPA ratio of 1 to 1 reduced plaque formation, serum lipid profile, and markers of inflammation in an experimental study. Increased availability of omega-3, particularly EPA, replaces arachidonic acid and exerts potent anti-inflammatory effects at the cellular level. Omega-3 are associated with lower levels of pro-inflammatory markers and high anti-inflammatory markers. And increased omega-3 has been proposed to suppress inflammation and disease. And now a closer look at common lipids to examine why omega-6 is so plentiful in the diet. All lipids, whether solid fats or liquid oils, are comprised of saturated fatty acids shown in red, monounsaturated fatty acids shown in blue, and polyunsaturated fatty acids, including omega-6 shown in green and omega-3 shown in yellow. Note that omega-6 and omega-3 often occur in the same foods, and usually omega-6 predominates, or the two are equal, but overall, omega-3 is scarce in foods that are commonly consumed. Let's look at canola oil. This is frequently named as a source of omega-3 fatty acid. It only contains a small amount of yellow, symbolizing omega-3. Now, cottonseed oil is one you may not be familiar with, but all you need to do is scan ingredient labels and you'll find cottonseed oil that has been added to processed food. Other omega-6 commonly found in fast foods, bread spreads, and salad dressings are soybean, corn, and sunflower oils. In contrast to omega-6, most DHA intake comes from eating seafood, which is infrequently consumed. The main fatty acid in cod liver oil is actually monounsaturated, and when looking at its polyunsaturated fatty acid components, it is made of equal parts omega-6 and omega-3. Fish oil supplements are sourced from fish livers, and dietary supplements of fish oil, DHA, and/or EPA should be presumed to contain omega-6 unless otherwise specified by speaking to the manufacturer. Omega-6 and 3 compete for the same desaturation enzymes, so higher intake of EPA and DHA can tip the eicosanoid balance toward less inflammatory activity. If only there was a way to reliably consume more omega-3. Cooked seafood containing 500 milligrams or more of EPA and/or DHA per 3-ounce 100-gram serving are considered high omega-3 sources. Every food on this list meets that definition. An additional source of omega-3 is flaxseed, but it does not contain EPA or DHA. Only marine origin omega-3 does. An omega-3 supplement that provides 500 milligrams of DHA and/or EPA, meeting the definition of a high omega-3 food, is a prudent guideline for those who don't consume seafood or those who are unable to meet their alpha-linolenic acid AI. This supplement contains 550 milligrams from EPA and DHA. Omega-3 supplementation has a long history of safe use in infant formulas, prenatal supplements, and it is clinically prescribed to reduce elevated serum triglyceride levels. Any fish oil supplement chosen should be mercury-free. This one states it has been tested for heavy metals. A large body of research dating to a review in 2013 suggests that omega-3 supplements do not prevent cardiovascular disease, and a more recent update found that high-dose omega-3 supplements did not prevent cardiovascular events after 42 months of follow-up. But current research also found that purified EPA has been shown to be effective in coronary artery disease prevention. High omega-3 foods or supplements can increase the EPA to AA ratio, a robust marker of future cardiovascular events. Omega-3 supplements should be devoid of omega-6. The manufacturer should be called to find out what the other fatty acids are supplied here. Highly likely they are not omega-3, or they would be called out by name and amount, because the higher the omega-3, the more marketable the product. Linoleic acid inhibits EPA incorporation from fish oil supplements. Here's another product. We see that there's 2,000 milligrams of fish oil, but 1,200 milligrams of omega-3. and calling the 1-800-consumer line verified that omega-6 was not removed from this product.
This is a pharmaceutical-grade omega-3 fatty acid product.
So 1-855-VAS-CEPA would determine whether omega-6 are part of the composition,
And it may well be that this is purified just to contain omega-3.
It's well established that inflammation plays an important role in the development of cardiovascular disease. There is no benefit from consuming less than the AI of omega-3 or an imbalanced intake of high omega-6 relative to omega-3, but most people underconsume seafood. Strong evidence from mostly prospective cohort studies, but also randomized controlled trials, have shown that eating patterns that include seafood are associated with reduced risk of cardiovascular disease. For those people unable to consume seafood on a regular basis, dietary supplements in physiological, food-like quantities
Can prevent deficiency and the adverse effects that would potentially accompany it.